Okay, so for velocity, if your so velocity is the displacement over time, which is also the change in position over time. So, and the change in position is your final position minus your initial position. So, velocity equals your change in position over the time. So, for example, say your initial position is negative 20 meters. Then, say your final position is 10 meters, and the time it took was 10 seconds. So, your velocity would equal 10 minus negative 20 meters, 10 meters, over 10 seconds. And so your velocity is equal to 30 meters over 10 seconds, which equals 3 meters per second. Now, say you are given, here, let's move this up. So, say you're given your velocity is equal to 10 meters per second, and your final position is 100 meters, and the time it took was 5 seconds. Now, so you're solving for your initial position, so let's call that x. So you would subtract it x. So, you would get negative 50 meters per second is equal to 100 meters minus x. And so then you would end up with x equals 150 meters. Now, so that is speed and velocity. Now, acceleration. So acceleration is equal to your change in velocity over the time. So, let's say another way you can write this is your acceleration is equal to your final velocity minus your initial velocity over the time. So, let's say that your initial velocity is, or let's say your final velocity is negative 10 meters per second, and your initial velocity is 5 meters per second. And the time is 3 seconds. So, you're trying to find your acceleration. So, that would be negative 15 meters per second over 3 seconds, which equals negative 5 meters per second. And that would be your acceleration. Now, okay. So going back to speed and velocity, let's say that you have a car, and it starts here, and it travels in the negative direction at 10 meters per second for 4 minutes. It stops here for 1 minute, and then it turns around and travels at a rate of 15 meters per second for 6 minutes. So that would be a total distance of, so this distance here would be equal to 2,400 meters, because that's how far you travel for 4 minutes if you're going 10 meters per second. And this distance from here to here is equal to 5,400 meters. So, if you take, so that's negative, in the negative direction. So, to find the velocity, you take the final position, which is 5,400, and subtract okay, so the displacement here is just 3,000 meters. So, if you take your displacement, which of 3,000 meters, over the total time it took, which this was 4 minutes in this direction and 6 minutes in this direction, so that would be, oh, but it stops for 1 minute here. So you have a total of 11 minutes. And so that ends up being about 4.5 meters per second. However, so that would be your velocity, because you're taking the displacement. However, if you're doing speed, then you would add these two, because you went this far plus this far. So that would be 7,800 meters total over the 11 minutes, because it's 4 minutes this way, you rest for a minute, and 6 minutes that way, 5 minutes that way. And so that would equals about 12 meters per second. So your speed and your velocity, so this is your speed, and your velocity is 4.5 meters per second, which is a fairly large difference. So then let's say we graph the if we take the position graphs of, say, throwing a baseball. So this is your time, and this is your position. So it would be a parabola, because as you throw it up, the force of gravity is acting on it and pushing it down and decreasing its velocity as it moves up, until it gets to the point where it stops moving, and then it goes back down. So if you're graphing the velocity for this position, of the velocity of the ball, it would be a negative sloping graph, because the velocity is the change in position over time. So that would be saying the change in position, which is this part of here, over this part right here. And that also gives you the slope of a line, which is and that's why, so the velocity is showing a constant decrease in position, in the change in position, because as you move up per second, then as you move up per second, it's changing at a constant rate. So then, the slope, this is the slope because it's the change in x, over the change in y. And that's also why if you take the derivative of this equation, then you get your velocity, because the derivative is also the same as the slope. So, the velocity is negative because your change in position is getting smaller and smaller each time until you reach here. And then once you reach here and you go down, your velocity is increasing, however, your change in position is decreasing. So that's why it stays at a constant velocity all the way down. And here is where it reaches 0, and that's this is where the ball stops moving, and so that's why the velocity is at 0. Now, the acceleration graph is a straight line, is just a straight line at a negative value, because this is your velocity is decreasing at a constant rate, or it's staying the same. Your velocity is staying the same, so that's why your acceleration graph is staying the same. And it's negative because the slope of your velocity is negative. So that is the difference between speed and velocity and between position, velocity, and acceleration.